Hello everyone, I'm back and I just recently went to and watched Jeremy's IT lab. Uh, I'm on on Spanning Tree and I believe that's already a part of CCNA2, but we'll see how this goes, right? We'll see how this goes. We got a couple of packet tracers from CCNA1, and if I'm able to do that, that means I've successfully understood at least CCNA1. These packet tracers are from the Neticat series. I found them online in a whole file list, so we'll be able to do these. Looks like SSH. I hope I remember what I'm doing for that one. But yeah, we'll start off with 1.5.7. Let's wait for it to load and everything. We'll be doing everything until 17.8. Okay, great. So let's go and let's press OK. And we'll start off with what it wants us to do. Oh, looks like this. Let's press the dock so you see what we're doing. Okay, let's just read this out real quick. Identify common components of a network as represented. There are end devices categories, custom made devices, multi-user connections. List the intermediary devices categories without entering into the internet. How many icons are in the topology represented endpoints? And without counting into the clouds, how many icons in the topology represent intermediary devices? How many end devices are not desktop computers? And how many device types? Okay, so let's go check out a notepad. Check out the notepad. Oh, this is from last video. We'll just open this up, right? So let's go do step one. We're gonna do question one. List the intermediary device categories. So let's see what we got here. Oopsies. Almost screwed that up. Okay, so what we have here, we have a intermediary devices. I guess what that means is that we're kind of I see a multi switch, right? Well, I think intermediary is more like switch to the router, right? So this the answer is gonna put switch um router host and clients, I guess. Host clients and printers. Printer and packets. So that's what we see. Switch. Oh, looks like we got wireless device, and phones. VoIP, voice over IP, by the way. Okay, we got step one down, right? Or not really step one, but like we got question number two. Without entering into the internet cloud or intranet, how many icons are in the network topology represented endpoints? Only one connection leading to them. Huh. I believe every endpoint is just these, so I guess it's 1, 2, 3, 4. Okay, so let's go see this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have about 14 endpoints. 14 endpoints. And then we'll see in the cloud, I guess. Without searching into the internet, I guess. Okay. Guess we're gonna have to go to Internet. Oops. What's going on? Where do we go? Oh no. Oopsies, we don't know where we're at now. Oh, there. Okay. Yeah, so I guess it's the internet. And I don't know what are we supposed to be seeing here, but looks like we got 14, right? Seems about right. Okay, without counting the two clouds, how many icons in this topology represent intermediary devices, multiple connections leading to them? Okay, we got some intermediary devices, so let's go and check this out. Intermediary devices. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I think we got 14 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, no. I think this one, these are both together. I guess it's like we got 16 endpoints if we're gonna continue with these two. So it's gonna be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we got 12. I believe this is 12 intermediary. Could be wrong, but you know, well, we're learning. Okay, how many end devices are not desktop computers, right? Okay, so let's go check out this real quick. If I got any wrong, just let me know. So 1, 2, 3, 4, 5 desktop computers, right? So 1, 2, 3, 4, 5, 6, 7, 7 end devices are not computers. Okay, number 5. How many different media type connections are used in this network topology? Media type connectors. We have 1, 2, 3, 4. 4 including wireless. So we have 4. Okay, cool. 4 media type connections. So the reason why we have 4 is because we have a serial, a serial. There's the connectors, right? We have a coax going to the modem. We have a serial going to each connection. And then we also have a regular straight through copper cable going to each PC and creating these what's it called, layered um topology, business topology for redundancy. Okay, let's go to step 2 now. Go step 2, right? Step 2. Okay, go get the first question going. Okay, the first question is explain the purpose of the devices. All right. Here we go. In Packet Tracer, only the server PT device can act as a server. Desktops or laptop cannot act as a server. Based on your studies, explain client server model. Um, Client server model. It's like this, right? 100% it's like um servers, right? Like servers, they give services to clients, and clients, they connect to servers. That's basically what it is. So the answer would probably be servers provide services to clients, and right, and clients use services from servers. That's basically it. That's your answer. But the thing is that a client can also become a server, and a server can also become a client. Or like, I don't know. I think it's like that. They can be interchangeable. I think a client can be a server because if you configure it right, you can. Okay, let's go for number 2. List at least 2 functions of intermediary devices. Okay, so let's see. 2 functions of intermediary devices. If anything, we can Google this. What's an intermediary device, right? What is an intermediary device? Okay, great. So it looks like our intermediary devices, they basically, they connect to more devices, or they allow endpoints to connect more devices. And other intermediary devices together. Okay, great. Okay, and then choose 2 criterias. So what you would want to do is that the 2 criterias that you would want is actually pretty simple. The 2 criterias is cost, right? Cost and bandwidth. That's basically it. Just cost and bandwidth. It's like if it's too expensive, it's too expensive for this network, then yeah, you know, you don't really want that to happen. But if it's also the bandwidth, like okay, how fast you really want these to happen or to work, then that's most likely what it should be. Okay, let's go to number 4, or step 3. Step 3. Explain the difference between a LAN and a WAN. A LAN is equal to local area network, which is also equal to basically, yeah, it's just a local area network. It's like an office building, right? Inside an office. Let's just say it's inside an office. And then a WAN is equal to a wide area network. It's like connecting, let's just say it's connecting building to building. Okay. So in the packet tracer network, how many WANs do you see? We see 1, 2, let's see, 3, 1, 2, 3. We see about 3 WANs. Yeah, about 3 WANs. Yeah, that's basically it. There's 3 WANs. If there's any, if I'm getting any of these wrong, just let me know. or if someone actually sees it. Okay, how many lands do I see? Okay, we'll see how many lands we got. Right, we got 3 lands. 3 lands and 3 WANs. Basically, it's like, okay, WAN, right? WAN is these little ports right here that kind of just go around, and then each LAN. So, you need one connection for, like, this is gonna be for your WAN right here. These WAN networks. Okay, the internet in this packet tracer network is overly simplified and does not represent the structure and form. Briefly describe the internet. The internet, right? Let's just say that the internet is um a way to connect to other computers over the web or something. Over the web. Question number 5. What are the common ways of home user connects to the internet? They can do from a home router, right? They can use a home router right here. See, home router and modem. A modem. And yeah, that's basically, it's just a home router and modem. That's how they can connect to internet. Then 6, what are some common methods that businesses use to connect to the internet in your area? Hmm. Oh, we can connect through like methods is like through serial, I believe. Serial cables, fiber, coaxial. You can connect through these mediums to connect but to the internet in your area. So like, yeah, basically it's like the coaxial right here, and then we got like a couple of serial cables, but mainly the coaxial will go in, and the businesses will use their serial cables to connect to the internet. Okay, let's see. Challenge question. Okay, well, let's try to see this. Okay, now that you have had an opportunity to explore the network represented in this packet tracer activity, you may have picked up a few skills that you would like to try out, or maybe you would like to opportunity. Add an end device to the topology and connect it to one of the LANs with a media connection. What else does this device need to send? Can you provide information? Is there a way to verify that you correctly connected the device? I mean, okay, so if you connect it, right, let's just say we want to add a PC. Let's go to end devices right here, you see? Let's go to end devices, network devices, okay? As you can see, there's also home, network devices, switches. These are intermediary. So if we like added a, let's say we added a PC here, right? What else does this, well, what it needs is actually an IP address. What it needs is an IP address, but you can actually do it through DHCP and automatic. We'll just do it automatically in DHCP. And then we'll just connect it through a copper cable. Here. Yay, internet, Ethernet 3 and fast Ethernet. And how do you know? As you can see that they are converging. This is the orange, the amber, and the green. That means they're converging. You're trying to figure out what's going on. And is there a way to verify that you've correctly connected the device? Well, time will only tell. If these two turn green, then that means they fully converged into the network. Let's go skip the time. There you go. Let's go. We just skipped at least 30 seconds ahead. And now they're fully converged. I believe you can ping. Let's just see. This is out of the scope, but if we do an ipconfig/all, we'll see our default gateway is this. And if we copy this, and then we paste it here, we'll try pinging our default gateway. If we can ping our default gateway, then that means we're able to connect. See? There you go. That's a way. Add a new intermediary device to one of the networks and connect it to one of the LANs or WANs in the media connection. What else does this device need to serve as an intermediary? Okay, so we get an intermediary. Mainly we're just gonna talk about a switch. So let's drag one in here. Here's our switch. Connected to one of the LANs or WANs. Okay, let's just connect it to a LAN. Let's just say, okay. The router's okay. I think it's best to put it here. We'll just put it in between right here. There you go. Let's put it in here and it will, yeah, we'll just put it in between, right? Add an extra redundancy. What else does this device need to serve as an intermediary device for others? Okay, so what it does is that it needs to just be connected to more. So let's, right, what we can do is this. Okay, what we can do is that we can put it in the middle here. And then we'll just try to have these connected to the switch. So we'll just take this connection. Take this connection right here, actually. Pass Ethernet 1, pass Ethernet 1. And we'll just take this, fast Ethernet 2, fast Ethernet 2. We'll take fast Ethernet 1, back to fast Ethernet 3. Okay, this is not practical, but this basically turns it into a medium. You see? Now it's like all connected to everyone. Notice how everyone's connected to each other. But you're also going to see that the STP will do its job. You'll just see it out. We'll just skip the time. And it looks like, you see, notice how everything's all connected now? Right? Look at that. Everything is all connected. Some are green, some are amber. It's because there's a concept called spanning tree protocol, and you'll learn that later on. And then here we go. Open a new instance of Packet Tracer. Create a new network with at least 2 LANs connected by a WAN. Connect all the devices. Investigate the original Packet Tracer activity. Record your thoughts and save your Packet Tracer file. Okay. Okay, we're just gonna make a new Packet Tracer now. Okay, let's save this. Oops. Okay, give me a second. We'll just save it. Save as. And then we'll also put this in here now because we already did it. Okay, so we'll save this file and then we'll open a new one. Okay, now that we have a new one, we'll just connect our LANs and WANs. Okay, let's just say that we want a, here we go. We'll just have this here. And then we have one router, which is going to be our WAN. And then, oopsies. Yeah, we'll just connect it to like a, yeah, we'll just do this. This is going to be as basic as it gets. Just connecting it straight through. So now we have 2 LANs right here connected by one WAN. If anything, we could put another router, but you know, that's basically it. That's basically the configuration. If anything, we'll just like configure it right now. Let's just do 192.168.2.1 or 2.2. And then 192.168.2.3. 2.1 seems about right. We'll configure this one as well. 192.168.1.2. Give it that. 192.168.1.1. And then we'll go to the router and we'll just give it its configuration. Conf IP add int show IP. Okay, that's G00. So let's do int G000 IP add 192.168.2.1 0 no shut. And then we'll also go to int this, and we'll just change this to 1, and give it a no shut as well. Now everything should be green now after I do all this. Let's give it a write as well to save the configuration. Right, give it a write, and then we'll do a show IP. Oh wait, no, just a show IP int brief. And here we go. Now we have everything all connected. Looks like we're up, and these two should be able to ping each other. So let's try pinging to the other LAN. Ping 192.168.1.2. This is 1.2 as well, right? Oh, there you go. So the reason why it didn't like ping out at first is because there's a thing called address resolution protocol, which is ARP. Basically it's just finding out where this like it's like finding out the MAC address and the IP address and what's going on and where it's at, and then it just like shoots it out of the router. So yeah, now this is a good example of one LAN, two LANs, one WAN, and that's it. That's actually it. I hope you guys like this video. This I know I was gonna do everything, but I think it's just best to have these like segmented and then show my process of how I know things. If there's anything wrong, just let me know. And yeah, thank you guys for watching.